Hello, everybody, and welcome to this year's talk on tips and tricks for querying MongoDB. This year, we're going to be talking about how to read explain plans for aggregation. This builds a little bit on the session that we did last year, but I think you really enjoy it and get a lot out of it. My name is Chris Harris. I'm going to be leading this session today. I am a staff engineer at MongoDB in the Technical Services Organization, and let's go ahead and get started because we have a lot to talk about. The first thing we have to say, though, is that I've actually already lied to you. As of this moment, I am now transitioning to a product manager role for the query team. So this means for this presentation that it was built with the experience of being a support engineer, helping you solve your aggregation performance problems for the last few years. And now going forward, I'll be even more interested in hearing your feedback about how we can improve the product. So overall, I think this is going to be a great change, and I'm really looking forward to working with you all in a new capacity. So another few things before we get started. The first is that for the purpose of this presentation, especially at the end when we look at explain plans itself, we're going to be focused more on the process of reading them as opposed to the nuances of little syntax here and there. As you can imagine, it is quite difficult to get a lot of text on these screens. So we're going to do the best that we can to look at this in an aggregate overview sort of way, no pun intended. The next thing is that you actually probably don't need much knowledge at all coming into this. You don't need much experience with MongoDB in order to benefit from this conversation. There are, however, some additional resources that I'll link to at the end that if you find this information interesting, you will also benefit from reviewing those things as well. And then with respect to applicability for this presentation, there's two things that I'd like to say. The first is that the information here is accurate as of 5.0, and anecdotally, this applies to basically any 3 or 4 MongoDB release. So anything since over the last few years, this is pretty much what you can expect to see, with minor differences, of course, as we've introduced new optimizations and things over time. And in addition to this, in terms of you in your role, this is basically for anybody who wants to make MongoDB go fast. You don't have to be a DBA, you don't have to be a developer, whatever it is. If you're interfacing with MongoDB, you are experiencing some questions about aggregation performance, you will likely benefit from this conversation. Great. So with respect to an actual agenda, we're going to talk about 4 general areas. The first is just going to be a quick one, which is why you don't actually need this presentation. It's always fun to do those items. The second is we're going to actually talk about aggregation land, specifically the second region. So we'll get to that a little bit further on. Then we're going to tell you why their explain plans are actually simple treasure maps, although they look a little complex at first. And then finally, we're going to explore aggregation land a little bit by practicing with some actual output that we can take a look at. So with that, let's go ahead and get started on the first item here, which is why you don't need this presentation. So there's a few reasons that I make this kind of odd statement, but the first is that there's a ton of tooling that's getting increasingly better over time. So for example, Compass has an aggregation builder, which really helps build aggregations themselves. You can take a look at what the different stages are, how things are coming together, and debug just a lot of logical issues there. And further to that, we've got a lot of automated tooling that is helping users identify missing indexes, for example. And so you don't even need to rely on having a bunch of knowledge about how an index works or anything like that in order to benefit from that tooling. The second reason is that there are a number of built-in optimizations for MongoDB. Specifically, as it relates to aggregations, there are a number of things that the system will try to do by itself in order to execute your operation as efficiently as possible. And so a lot of the time, this just happens under the hood, and you don't need to worry about it or even think about it, which is great. We'll actually be talking about a couple of these as we go along. And the final thing is that in terms of support, there's a number of options that you have so that you don't, again, have to necessarily become an expert yourself. You can rely on the community to do this. So just as a reference, we do have professional support that you can reach out to if needed. But in addition to that, the community is really great. And I would strongly encourage you to visit our developer hub, where there's a bunch of questions about aggregations and how to do them in best practices type ways. So those are all great options and why you might not need this presentation, but that's of course not why you're here. So let's go ahead and get started with talking about what aggregation land is. And to do that, let's revisit Queryland from last year. Again, you don't have to have seen the presentation from last year to benefit from this, but what we generally talked about was that In MongoDB, we can think of Queryland as a bit of an island. What we'll end up having is a query that comes in on one side of the island. The goal is for it to traverse the database and find the information that we want, and then it comes out on the other side with a document or a set of results. So what we did last year was we actually broke down the island into 4 regions. So we said there's plan generation, plan efficiency, plan selection, and plan cache. So each of these controls a different aspect of how that query arrives and then again traverses across the landscape of the island to identify the documents, the result set in the most efficient manner, or in other words, to find the treasure that's buried in the island as fast as possible. So these are all some fundamental things about how the initial data retrieval happens, but let's expand on this just a little bit. So again, we have these 4 stages, and then we made the comparison that explain plans are really just treasure maps in this regard, and those treasure maps, those explain plans, have these same 4 regions. So when we're looking at a basic explain plan without aggregation, what we want to do is try and figure out which region that we're in, which region that we're trying to go to, and then we can use some just fundamental understanding of those things to manipulate the operation to execute in a more performant manner. Some of these manipulations would include things like building a new index or changing the shape of the query in some way. So how does all of this relate to aggregations itself? Well, it turns out that if we take Queryland, it's actually, we're just going to push it over here to the left, and we're just going to call that Queryland. But now we have this whole section on the right, and this is basically aggregation land. So these two actually coexist by each other. And what the pirates in the optimizer would like to do is hide the treasure as close to Queryland as possible. It's a little dangerous to go into aggregation land, and there's no need to explore that unnecessarily. So let's go a little bit further into that, and let's test that claim that I made earlier, that an explain plan for an aggregation is actually a simple treasure map. Because for those of you that have worked with aggregations before, you can know that they get quite verbose in some situations, and that verbosity will again translate into the explain plan. So it's a little bit at odds to maybe see a claim that the fundamental architecture of the treasure map is simple. So let's take a look at just the basic outline structure of an explain plan for an aggregation. So if you run an explain for an aggregation, you will get something like this, where the dots obviously represent a bunch of extra information. But structurally, this is what you would generally see. You would see stuff here like the standard metadata that has server info, such as the version. You would see OK1 because the command executed successfully. This is all just pretty standard stuff that doesn't come into play often unless you need to double check the version that the command was run against or something like that. There are new things in 5.0, such as command itself. So this is useful for actually taking a look at what operation the database received, as opposed to what happens after it parses that operation and goes to execute it. So there are some interesting and awesome things that the optimizer will do, but it's sometimes just useful to see exactly what was initially sent to us. For example, did that operation have a sort stage or not? And then finally, for the heart of this presentation, we care most about this stages array that is going to contain the vast majority of the information in the output anyway. And it's also got the most important information when it comes to trying to figure out what we're doing when we're reading this plan. So specifically, the key here, the one thing that you should take away from this presentation is that Queryland lives exclusively in this first $cursor entry in the stages array. So anything here is going to be what's called pushed down to the query optimizer and for data retrieval. And then everything after that, all these extra stages, this is where aggregation land happens. So what's going to end up happening is the database is going to retrieve an initial set of results from the collection, and then anything that it can't do in that initial retrieval, it is going to follow up and do those in these aggregation stages later in the process. There are, of course, some exceptions to this. So one famous example would be $lookup. In a subsequent $lookup stage, we would obviously have to go do additional data retrieval. But generally speaking, this is the mental model that you should have when you're looking at an explain plan. And again, that mental model is that the cursor stage belongs to Queryland, and all of the other stages are in aggregation land and executed separately. So what does that actually look like with our little visual from a while ago? So if we want to simplify the explain, we're going to start at and just focus in on the stages themselves. And again, we're going to take this first entry, which is always going to be $cursor, and we're going to mentally put that over in Queryland. Then we're going to take any remaining stages that are listed in here, and we're going to push all of those into aggregation land. And so what we end up with is just an array of stages where the first one is in Queryland, the remainder of them are in aggregation land. Okay, great. So I've made claims about why this mental model works, but I think the best thing for us to do is actually to test it by giving it a spin with an example. So in this scenario, what we're going to pretend is that we have some game data in our database. So we're a gaming company. We host a number of different games that players can play. And for the purpose of this discussion, each document in here is going to represent one round of one game played by one gamer or user. And the goal of what we're trying to do at the moment is we're trying to calculate some properties of the top rounds. So what you're going to see in a moment is we're going to look for a game called Minesweeper, because I love that game for no reason. We're going to look at specifically the top 100 rounds that the gamertag ACE has played, and we're going to pretend that we're calculating some mathematical numbers around this, such as the average score for those top 100 games. So with that in mind, our initial aggregation might look something like this. We'll start off and we'll have a $match because we want to find the documents that correspond to a specific game. Again, in this case, the game Minesweeper. But we also said that we want to limit the documents to a specific gamer. So in this case, we're going to look for gamertag ACE. We're going to try and be smart here because we know that all we're going to end up doing is using the score in those documents because we want to use that to calculate the averages and stuff. So we're going to try and be smart and help the optimizer here by just saying all the data that we want is score, and we don't actually need anything else from the documents. And so we'll see how that turns out as we go along. The next thing we want to do is, again, we're looking for the scores from the top 100 rounds, for example. So we're going to actually sort the documents that we find so that they are in descending order. Again, so the top scores are the first 100 that we look at. We're going to limit them to 100. So if I have played 10,000 games of Minesweeper, not saying that I have, then we will just be able to find, again, the scores for the top 100. And then finally, the remainder of the action here is to actually do the calculations, and this is going to happen in a group stage. So there's just two aspects to this for what you're going to see on here. The first is that all groups need an underscore ID, and in this case, we know that all of our documents belong in a single group, or in other words, we want to collapse all 100 documents down into a single one because we're calculating all those. They belong in the same group, and we're calculating all those numbers together. And then we're going to do the actual stuff that we want, such as build an average score field using the $AVG operator for average, of course. And then if we were to do any of the other things that I had mentioned on the previous slide, such as minimum or maximum, or do some standard deviation stuff, we would also include those here inside of this group. So this is the basic aggregation that we are looking at. And now what we're seeing on the right over here is the stages array that is going to be in the explain output when we gather that information from the database. And again, we think at this point that we have created an index that is going to help us achieve our results. We have tried to do what we think are smart things by requesting only specific data. So the database doesn't have to work as hard by processing the documents unnecessarily. And generally what we see here is that output. So a few things here. As I mentioned before, the very first entry in the stages array is always going to be the $cursor. So inside of here basically is where Queryland lives. So if you have looked at an aggregation for, an explain plan for a normal find operation, the stuff in here is basically reflective of that. So you see the different stages here, and there's actually a lot more information if we were to blow this up and show everything. So then next, outside of Queryland are the remaining operations like we talked about. This is where aggregation land lives in this explain plan output. So right here we have a sort and a group, and that's what is happening outside of Queryland separately in order to process the data. So let's go and just quickly match up what we see in the explain output, which is after the database has gone through and attempted to optimize things and do things in the best manner possible, versus what we actually requested at the beginning. So there's a number of observations that we have right off the bat. The first is that we're going to start backwards in this case because it's a little bit easier. So we have our $group here on the left from the operation that we submitted, and obviously that maps pretty straightforward to the group on the stages explain output. Moving up on the left, though, we see that both the limit and the sort are over here, and they've actually been applied to the next thing on the stages array output, the entry in the middle, which is a $sort stage that includes limit as a parameter. So during the execution of this sort by the database, it is going to go ahead and include the limit while doing its work. And then finally, that implies that the remaining stuff up here on the left, which is the $2 matches and the project, are happening over here in Queryland on the right. So the question though is, can we do better even if we don't know much about the optimizations that are available to MongoDB, and we might not necessarily know all of the best practices when it comes to writing aggregations today? And the answer is yes. So let's apply this little framework for looking at the explain output. Let's try to do what the pirates and the optimizer do and push as much down to Queryland and pull it out of aggregation land as we can, and we'll see what happens. So again, here is the output from our explain plan that we were just looking at. And the first question that sort of comes to mind is, why the fetch in Queryland, right? So if we take a look, we do have a stage from that execution where we see the projection is happening because we've requested only a specific score field. And when we look inside of that and expand it out in the full output, we see an entry here called transform by. And indeed, we see that just score, the field that we requested, is in there. But in addition, there's like an underscore ID field here that says true. But we definitely didn't request that when we made the projection, right? So over here in the original operation that we sent to the database, let's try something different. Let's assume again that we don't know all of the little caveats about project, and let's just say that for sure we don't know exactly where the underscore ID was coming from in that transform by statement, but we know we don't want it, so let's try explicitly adding that to our request. So now we've added that into the request, we send it to the system and gather an explain plan, and this is what comes back. And it's going to have some modifications. So the first modification from the original one is that our fetch stage is no longer there. So our original goal of allowing the database to save some work by not processing the whole document is now being achieved because we no longer have to fetch the whole document. We're gathering the data that we need from the index scan itself, which is great. The next thing that happens in terms of changes from the earlier explain output is that our projection changes to a projection underscore covered, which again implies that we are gathering all the information we need from the index scan itself, and we don't actually have to go fetch the document for further processing by the database. So this is great, and we've made huge progress here. Just as a sidebar, the thing that happens here with project is that underscore ID is always included by default. So this is a special field, obviously, in the document for MongoDB, and there's special behavior here when it comes to project. So if you don't want the underscore ID value, you have to explicitly request that it's off. And then the other thing to keep in mind here is that even if the index that you are using, which in our case, you'll see that in just a moment, does have the other fields that we want, it does not have the underscore ID field included in it by default either. So again, those two things were what we're working together to result in the fetch, which we didn't need. So that's great. We've now sorted out the first thing here. And so now the output on the right is the updated output. And I've also included the index name here, which again has the fields of game, gamer tag, and score. And again, the idea here is to leverage that to find the documents that we want from our match, be able to retrieve the values that we want, which is just score, without fetching the documents, and also to use that index to walk that index in order to provide the sort. So the next question here, though, is if we are going to walk the index to get the requested sort order, and that would happen in Queryland, then why do we have a sort stage here listed in aggregation land, especially one that includes the limit? So that's an open question of why a separate sort. So to dig into that a little bit, and again, assuming that we don't know every little detail or every little nuance of how the optimizer works, we can just make a simple observation here on the left, which is we have a $sort stage request, and it's followed by the $match stuff, or it follows the $match stuff, excuse me. But the projection that we're requesting is right in between that. And again, the whole reason that we think we're providing the projection is because we're trying to help out the optimizer, right? We know that the database only needs to retrieve this score field, and we're trying to help it by telling that explicitly. But still, we have this stage that's smashed between the stuff that we want to run together in Queryland. So maybe as a test, we could simply take this stage out and just see what happens. Again, generating an explain plan is pretty simple and straightforward. So there's no harm in just taking a look at what changes when we make to the initial aggregation, how those are then reflected in the explain output. So what we get back looks like this, and let's walk through what the changes are from the original. So the original looked more like this, and the first things that happen is this $sort that we had originally, it's now gone completely from the stages array. So originally we had the 3 entries in stages, 1 for the cursor from Queryland, and then 2 for aggregation land. The sort is now gone, which is what we wanted. Now we also see that there is a limit stage that has been now pushed down into Queryland, which is good. And then the other thing that's happening is we are now actually able to leverage that index to walk it in order to get the requested results. And that is why this limit stage is now being applied in Queryland, because the sort is also happening via the index scan down there. So in the end, our aggregation gets simplified down to what we see on the left, and the explain output on the right is what it ends up looking like. And this is a pretty good thing that we want to see. Now, just as an additional note for clarity here, the database was actually smart enough to figure out what fields, what dependencies we had on the document, and it applied that itself, right? So instead of the user having to request that via a $project, the database is able to figure that out on its own and go include that in Queryland, and we don't have to do that. And then the other thing that happened is that because we no longer had this explicit project that was that the database was thinking was needing to be done, we got rid of that, and everything was able to get pushed down even more into Queryland, which is again where the pirates usually like to hide the treasure as much as possible. So a few additional thoughts before we close for today. The first is that there's a ton of optimizations. We just had a short time together today. There's a documentation page that goes over some of these. Probably the most important one that I didn't go over today was the fact that stages do swap. So in certain situations where the output of the result set is still logically the same, the optimizer will be able to reorder things so that it can be done in a more optimal manner. The main thing that we saw today was just stage coalescence with the 2 matches being combined together, and we obviously saw this stuff pushed down into Queryland. There are a number of improvements in 5.0 explain output. These are probably the most substantial improvements I've seen to explain over the last 4 years or so. My personal favorite is that $lookup now includes some metrics about execution, which is amazing. You can now get an understanding of if you're doing some collection scans in that situation, how many documents are being examined, and this information is really critical. So please don't ever think that all you need to do is try and get stuff down into Queryland in order to improve aggregation. You do also need to take a look at the output of the other stages, and I would highly encourage you to do verbose explain plans with metrics so that you can find how these other stages are executing and potentially make changes there, such as ensuring that you have an index on the lookup that it is going on. Then, as I alluded to earlier, there are a number of other resources available. So there are previous talks. I have given a few talks on query performance. So if this is interesting to you, I would definitely encourage you to go back and look at some of those. My colleague Asia does a number of fantastic talks about aggregation. She knows basically everything about it. So I would highly encourage those. There's a number of blog posts by colleagues and friends that talk about, for example, the ESR index key guidance, which is how you should generally order indexes. And then, of course, we have the free MongoDB University. Specifically, we have a course called M201 MongoDB Performance that goes into a lot of indexing topics. So with that, what we talked about today was why you don't need the presentation. We talked about how Queryland is just half of the island and aggregation land is the other region. We claimed that the explain output, although verbose, is actually pretty simple, and we gave you a framework for thinking about that. And then we did a little bit of practice to just explore some of those ideas to help you understand how to use them when you're looking at an explain. So with that, I want to thank you very much for attending this session, and I hope you enjoy the rest of the conference.